Good evening, everyone. YouTube people, good evening. Zoom people, good evening, everybody. Hello. Good evening, guys. Maitri, homework question. Good evening, everyone. Yes, Babu Nanu. Good evening, everybody. Good evening, students. Am I audible and visible? Everybody can see me and hear me properly? Good evening. Homework. Did you eat, sir? Yes, I had lunch in the afternoon. My health is not very great today, but still will be able to manage. Actually, I had sore throat and little bit of cold and cough in the morning. So, but I have done lots of betadine gargles, so I'm feeling much better. Snacks, I will have it after the class, Jaspita. Good evening, everyone. Hi, everybody. But I hope everybody can see me and hear me properly right now. Yes, I'm taking very good care of myself. Don't worry. Thank you so much, though. All right, so let's start with the class. And first of all, I had given you two questions yesterday. Yes, all is good. Don't worry. So first question we will do. Question was how to calculate the percentage loss in mass. It's much better. Percentage loss in mass for magnesium carbonate. Let's start, everybody. Okay. So question was that find the percent loss in mass. Find the percent loss in mass on heating. Find the percent loss in mass on heating. 52.3 looks correct to me, Lakshmi Nam. Okay. Find the percent loss in mass on heating. MgCO3 solid. Percent loss in mass on heating. MgCO3 solid. So boys and girls, MgCO3 solid upon heating, the reaction will be similar to calcium carbonate. Okay, same kind of reaction will take place. Yes. So MgCO3 upon delta means heating, this triangular sign will go into beta MgO solid plus CO2 gas. Okay, this is the reaction which will take place. And like I told you yesterday only, that for loss in mass, we assume that the reaction is being carried out in an open vessel. So as a result of that, whatever gas is there, that will escape out of the system. Whatever gases are there, that will escape out of the system. So now, let's say that we have to calculate the percentage loss. So let's say that initially we have 1 mole of magnesium carbonate. Now, I remember it very well. Some of you yesterday had a doubt in this, sir, from where did this 1 mole come? Okay? From where did this 1 mole come? Because this 1 mole is nothing but an assumption. Okay, we have to assume because we are calculating the percentage over here. Now, percentage is like a ratio. Okay? So you can assume 1 mole, 2 mole, 3 mole, 10 mole, 1000 mole. But as I said, let us assume some cube number. Okay? So initially I said that let's say we have 1 mole of magnesium carbonate beta. Now 1 mole of magnesium carbonate on heating, the ratio is, you can see 1:1:1. Okay, 1:1:1. So 1 mole of magnesium carbonate on heating will give you 1 mole of MgO and 1 mole of CO2. 1:1:1 is the ratio, guys. Okay, and CO2 is a gas, and I told you that reaction is being carried out in an open container. So we have this 1 mole of CO2 being a gas, this will escape out of the system. This will go away from the system. Okay. So therefore, due to that, there will be some loss in mass, and that loss in mass will be equivalent to, the loss in mass will be equivalent to the mass of 1 mole. Sir, you and physics, sir, both are cousins. No, we are just good friends, not cousins. So by 1 mole of CO2 will escape out of the system, and the loss in mass will be equivalent to the mass of 1 mole carbon dioxide. So 1 mole carbon dioxide will go out, and mass of 1 mole carbon dioxide is 44 grams. Okay, this much CO2 will go out of the system, and whatever is the mass of 1 mole carbon dioxide, that will represent loss in mass. Okay. So loss in mass will be mass of 1 mole CO2, which is equivalent to 44 gram. And now is the time for us to calculate the initial mass. Initial mass means beta mass before the reaction. Before the reaction. So before the reaction, you had 1 mole magnesium carbonate. This is what was present at the starting before the reaction. Okay. So 1 mole magnesium carbonate was present. And what is the mass of 1 mole magnesium carbonate? Everybody. Carbonate, I have told you so many times, 60. Carbonate is 60 and magnesium is 24. 60 plus 24 is equals to 84 grams. This is the initial mass. Will you teach the same topic after coming to college? Yes, I think all the things will be taught one more. Don't worry. Okay, boys and girls. So now we are in a position to calculate the percentage loss. Percentage loss will be equals to the loss upon original. So loss is 44 upon original is 84 into 100. Now this calculation can be done. This gets cancelled by 4. So this becomes 11 and this becomes 21. Okay, 11, 21. So now this will be 11 by 21. So 1100 upon 21 percentage. 1100 upon 21. Okay. So if you solve it like, see, if it was, listen to me carefully. If it was 22, then it will become 50%. But it will be slightly more than 50 because denominator is less than 22. Did you understand that logic? See, in NEET, this is also a great technique. That is, you don't actually have to solve the question. You must always use option elimination. See, if this was 22, listen to me carefully. Try to cultivate this thinking. These are the things which separate good students from extraordinary students. Okay? So if in the actual lead question, beta, 4 options will be there, na? In the actual lead question, 4 options will be there. Now looking at this value, I am able to make out if this was 22, then answer would come 50. But it is not 22, it is less than 22. So if denominator increases, then the value, if denominator decreases, then the value increases. So answer will be more than 50. So all of you are telling me it is 52.3%, so I will go with that. So more than 50% will be the answer. If this was 22, how loss in mass is 44 gram, beta 1 mole CO2 mass is how much? Can we take calculator to NEET exam? No, bhai Ashwan. You should not even think about that. Beta 1 mole CO2 mass, beta 2 oxygen 32. 16 plus 16, 1 carbon 12. So 1100 upon 21. Okay. And if you want to do the exact calculation, that can also be done. Yeah, not a big deal. You can divide like this, na? 11 by 21. So put a 0 over here. So you will get a 0 point. Then 21 into 5. Okay, will be 105. So 5 will be left. Then put a 0 once again. So 21 2s are 44. So 0.52 you are getting. 0.52 into 100 will be around 52% only. Is this okay, everybody? YouTube people, Zoom people? Understood? अरे तो परसेंटेज कैसे निकलेगा भाई? Gayatri ma'am, how will you get percentage means what? If out of 40 marks you got 30 marks, then what is your percentage? 30 upon 40 into 100. That is the way to calculate percentage. So percentage loss is loss upon original into 100. Loss upon initial into 100. That is percentage loss. That is percentage loss. Understood, everybody? Is this clear, all of you? 21 times 2 is 42. Oh, sorry. Yes. Sorry. Yes. Of course, it is 42. We are doing Siva. Don't worry. Okay, this question is clear. Everybody, quickly give me a thumbs up. All of you on both the screens. Quickly. Everybody understood? Everyone, can we move on to the next question now? All of you. Good, very good. चलिए, so let's move on to the next question now. Sorry for this small calculation mistake over here. चिन्ह calculation mistake. 21 twos of 42. ठीक है, चलिए, very good. So now we will go on to the next question. The second question was for KClO3. So KClO3 equation is 2KClO3 solid goes to 2KCl solid plus 3O2 gas. This is the equation. Okay. Now over here, initially you can assume either 1 mole of KClO3 or better to assume 2 mole of KClO3 because then the ratio becomes simple, na? 2:2:3. 2:2:3. Okay. So let us say we have 2 mole of KClO3. Now some of you must be saying, sir, but why this is cheating, sir? Why are you taking 2 mole? In previous questions you took 1 mole. But here the ratio is 2:2:3. You can take any number of moles. Even if you do with 1 mole, you will get the same answer. For your mental peace and mental satisfaction, I will do it with 1 mole also. Don't worry. So let us say we have initially 2 moles of KClO3. So 2 moles of KClO3, this is the starting amount, will produce how much of O2? 2:3. 2:3. 2 moles of KClO3 will give me 3 moles of O2. Now, this 3 moles of O2, boys and girls, this 3 moles of O2 is the gas. So this will escape out of the system. Escape out of the system. Reaction is going out in an open container. So therefore, loss in mass will be equals to this much. Loss in mass will be equivalent to mass of 3 moles of O2. Can everybody tell me what will be the mass of 3 moles of O2? Loss in mass will be the mass of 3 moles of O2. Can everybody tell me what will be the mass of 3 moles of O2? Yes. For O2, my dear students, for O2, the molar mass is 96 grams, 32 grams per mole. For O2, 16 plus 16, 32 gram per mole is the molar mass. So mole cancel and we get what? We get 96 gram. 96 gram. And what, my dear friends, therefore will be the initial mass? What will be the initial mass? Okay. Initial mass will be the mass of 2 moles of KClO3. So 2 moles of KClO3 is what you have initially. And molar mass of KClO3, I think we calculated yesterday also. Molar mass of KClO3, I believe we calculated yesterday also. It was 122.5 gram per mole. So mole cancel. And this is 245. 245. Okay. And therefore your percentage loss will be 96 upon 245 into 100. 225 नहीं 245. Okay, 96 upon 245 into 100. This will be the percentage loss in mass. 96 upon 245 into 100. Whatever is that. Percentage loss will be equals to. Percentage loss will be equals to 96 upon 245 multiplied by 100. Further, whatever it comes, that will be your answer. Okay. Now listen to me. One more thing. In case you are having this doubt, कि sir, but sir, this is cheating, sir. In last 2 questions you did with 1 mole. Now you are taking 2 moles, sir. This is not fair. But you can take any number of moles here. Eventually, you are calculating a ratio. Okay. So suppose you start with 1 mole. Okay. So if you have taken 1 mole of KClO3, then how much O2 will be produced? See, now you will have to apply grandpa. Na? Yes, Mansa, very good. 2 moles will produce 3 moles. So 1 mole will produce 3 by 2 moles. 2 moles of this is telling me the ratio. Okay. By moles of KClO3 upon 2 is equals to moles of O2 upon 3. So suppose if you consider 1 mole of KClO3 beta, 1 mole of KClO3, then moles of O2 will be how much? Moles of O2 will be equals to 3 by 2 mole. If you put 1 over here, yes. So basically what I am trying to say over here is, I have solved the question assuming 2 moles, so therefore I got 3 moles. If you consider 1 mole, that is half, then this will also become half, na yaar. This will also become half. So as a result of that, your loss in mass will also become half, and initial mass will also become half. So ratio will remain the same. Are you able to understand this, everybody? You will get the same answer, whatever moles you assume. Suppose if somebody says, I will take 1 mole, yaar. If I will take 1 mole. So if I will take 1 mole, then O2 obtained will be 3 by 2 mole. So now loss in mass will be half of what you have got over here. But original mass will also be half of what you have got over here. So both these things will become half-half. Percentage finally will remain the same. So you can, idea is you can do with any number of moles, that does not matter. Preetham, this doubt was equation will be given or not. This was asked yesterday also. So I said that initially right now you are in the stage of growing up. So initially equation might be given, but as you mature and you get to know about more and more equations, so sometimes it might not be given also. शॉर्ट ट्रिक इसमें कुछ सर ये शॉर्ट ट्रिक मोल्स वाली हाँ भाई इसमें कोई ऐसी समझने वाली बात ही नहीं है ना. यू हैव अंडरस्टूड द क्वेश्चन बिफोर दिस. CaCO3 and MgCO3 questions are clear or not? The two questions which we did before this. So it is the same question, na bhai? And this time this O2 is the gas. So let us say we have 2 moles of KClO3. Let us say we have 2 moles of KClO3. So 2 moles of KClO3 will be giving me what, beta? 3 moles of O2, na? Because between KClO3 and O2, the reaction which is taking place is what? Reaction is 2 KClO3 goes to 2 KCl plus 3 O2. And question is saying that find the percentage loss in mass on heating KClO3. Alright. So let us say that initially we have 2 mole KClO3. 2 mole KClO3 will produce 2 mole KCl and 3 mole O2. 2:2:3, this is the ratio. Now O2 is the gas. So O2 being the gas will escape from the system. So what is the mass of 3 mole O2? Mass of 3 mole O2 is 3 into 32. 3 into 32 is 96. So 96 gram becomes your loss in mass. 96 gram becomes your loss in mass. And what is the initial mass, bhai? What is the initial mass? Initial mass is 2 mole KClO3. 2 mole KClO3 mass will be multiplied with molar mass of KClO3. Molar mass of KClO3 we calculated yesterday also, it was 122.5 gram per mole. So 2 into 122.5 will give you 245. This is your loss. This is your original. Loss upon original into 100 is called percentage loss. Same type of question. Same type of question. Is this clear, everyone? Same type of question, everybody. No, those 2 students who had a problem, have they understood? Okay, very good. Chalo, sometimes you can have questions where water of hydration is present. You know that dot H2O type of molecules? Hydrated salts, Na2CO3 dot 10 H2O, CuSO4 dot 5 H2O, MgSO4 dot 7 H2O. Yes. So in case of hydrated salts, the loss in mass The loss in mass is due to, first note down this point. In case of hydrated salts, the loss in mass is due to loss of water. In case of hydrated salts, the loss in mass, see, right now you are assuming the loss in mass due to gas. But if hydrated salt will be given, then loss in mass is due to loss of water. Loss in mass is due to loss of water. Okay? First note it down quickly. Like for example, if I take CuSO4.5H2O solid, this is called a hydrated salt wherever .H2O is present. So if you will heat it, then what will happen, beta? It will form CuSO4 solid plus 5H2O gas. Okay, so because of this water getting removed from here, there will be a loss in mass. So for hydrated salts, the loss in mass is due to loss of water. And this form, which contains the water, is known as the hydrated form. This is known as the hydrated form. Okay? And this form, which is removed from water, no water, is known as the anhydrous form. Is known as the anhydrous form. Okay, everybody, this is known as the hydrated form, this is known as the anhydrous form. So let us do a very fantastic question based on this also. Yes, this is also called as blue vitriol. Very good, Pawan. This is known as blue vitriol. So for hydrated salts, the loss in mass is due to loss of water. So suppose if I give you a question over here, Na2, a hydrated salt, Na2SO4. अरे delta means heating, यार. Delta means heating. I think I have said this 4-5 times earlier also. Delta over the arrow means heating. Heating. This is happening on heating. Okay. All right. So a hydrated salt, Na2SO4 dot NH2O weighs 1 minute 26.8 gram. 26.8 gram. Okay. On heating, yes, that dot H2O is called water of crystallization. A hydrated salt Na2SO4 dot NH2O weighs 26.8 gram. On heating, it leaves behind a residue of 14.2 grams. Find the value of N, and remember, find the value of N. And remember, residue meaning I explained you yesterday. Residue meaning I explained you yesterday. Okay, so quickly note down this question. Let's have a look at it. I'll give you a small hint, and then remaining. Yes. So listen to me carefully, everybody. Have you all noted the question? This is a fantastic question. Let's discuss it. Previous slide. Somebody is asking for the previous slide. Quickly note it down, everyone. Okay, 5, 4, 3, 2, 1. Change. Great. Chali, quickly note down the question. I'll give you a hint and then you will solve it on your own. Okay, so let's discuss this problem. Na2SO4 dot NH2O solid on heating will go into what? Can you complete the equation? It will go into Na2SO4 plus NH2O. Na2SO4 plus NH2O. Okay. Now, how much salt we have taken initially? How much salt we have taken initially, everybody? How much salt have we taken initially? One more कहाँ से आ गया यार? अरे look at the question. We have taken 26.8 gram. Initially, we are starting with how much of the salt? 26.8 gram. All right. Yes. And when we heated 26.8 gram of the salt, then water went away from it there. Water was lost. And the remaining mass was 14.2 gram. So 14.2 gram is the mass of what? 14.2 gram is the mass of what? 14.2 gram is the mass of what? Water. Arey, water is not the residue, bhai. Sodium sulfate is the residue, na beta? Yes. So 14.2 gram is the mass of sodium sulfate. So 26.8 gram was the total mass of the hydrated salt. From there, water got removed and 14.2 gram is left. So can any smart person over there tell me that what is the mass of water? Mass of water. Can any smart person over there tell me that what is the mass? No, molar mass nahi, mass of water. I am not asking for molar mass of water. I am asking total mass of the hydrated sample. Think like this. Don't look at the equation. Hydrated salt was there. So this hydrated salt had a mass of 26.8 gram. This is your hydrated salt. Once you heated it, beta, you got the anhydrous salt. And anhydrous salt has a mass of 14.2 gram. So remaining mass, law of conservation of mass is there, na? So water must be how much? Water must be 12.6 gram. How did we get this? 26.8 minus 14.2. 26.8 minus 14.2. Is this clear or not, everybody? 26.8 minus 14.2. So mass of water is how much? 12.6 gram. So 14.2 gram sodium sulfate obtained, 12.6 gram water obtained. 14.2 gram sodium sulfate obtained, 12.6 gram sodium sulfate, 14.2 gram sodium sulfate obtained, 12.6 gram water obtained. Now I can calculate the moles of sodium sulfate. Then I can calculate the moles of water. Beta, n has to be a whole number. 0.7 is not correct answer. Then we will apply grandpa on sodium sulfate and water. I can write moles of sodium sulfate upon T1 is equals to moles of water upon n. Moles of sodium sulfate upon 1 is equals to moles of water upon n. Grandpa on sodium sulfate and water. And calculate the moles of sodium sulfate and water. Put the values over here. You will get the value of n. Now everybody try it. Sodium sulfate, this is the mass. Water, this is the mass. Now calculate moles of sodium sulfate. Given mass by molar mass. Calculate the moles of water. Given mass by molar mass. And now put the values over here. Once you will solve, you will get the value of n. Try it, everybody, quickly. And remember, n has to be a whole number. N you will have to give a whole number. I am sure you will ask me the doubt, sir. Then what about gypsum? Okay, sir, it is CaSO4 dot half H2O I have learned, plaster of Paris, sorry. So beta, that is 2 CaSO4 dot H2O. Okay, you represent it in that manner. Can we use one? This is Y map only. Calculation of moles is Y map everywhere, Pawan. Chalo, so now what we will do is we will calculate moles of sodium sulfate. Moles of sodium sulfate is beta given mass upon molar mass. So given mass is 14.2 gram upon molar mass of sodium sulfate. Sulfate is 96 and sodium is 23 plus 23, 46. So sulfate is 96, 23 plus 23, 46, total 142 gram per mole. So how much does this become? 0.1 mole. 0.1 mole. And moles of water? Moles of water will be how much? 12.6 gram. So 12.6 gram is given mass upon molar mass. Molar mass is 18 gram per mole. Molar mass of H2O is 18 gram per mole. 18 sevens are 126. So 0.7 mole. Now put 0.1 over here. Na is 44. No, who said that? Na is 23. Na is 23 beta. So 0.1 over here and 0.7 over here. So eventually you will get the answer n is equals to 7. N is equals to 7 is the answer. Is this clear, my dear kids, everybody? Sulfur is 32. SO4 is 96. N is equals to 7 is okay, everyone? All of you? N is equals to 7 is fine, everybody? Chalo, quickly note it down. Next, we will start with the concept of very interesting concept, limiting reagent. Question is slide is this. Quickly write it down. You will get the QR later on. Don't worry about it. Okay. Let me check whether it is working today or not. 1 minute. It's working today. So you will get the QR and let's move on to the next concept. That is the concept of limiting reagent. Limiting reagent. Very interesting, very important concept. Final answer is 7. Yes. So limiting reagent, guys, pay attention now. Now limiting reagent is something which is very practical, and you can see so many examples related to it in everyday life. Okay, suppose there is a factory which is manufacturing pens. Okay, so you can think about a pen. Let's say this is a pen over here. Now every pen comes with 2 caps, one in the front and one at the back. So there is the body of the pen, and you have 1 cap at the back and 1 cap at the front. Okay, so and when the body and the cap will combine, you will get the final product, that is the pen. Okay, now in this factory the ideal situation should be what? That for every body 2 caps should be manufactured. This is the ideal situation, that body and caps should be manufactured in the ratio 1:2. For every 1 body I should have 2 caps, and this represents an ideal situation. If this will happen, then all the bodies and the caps will be totally consumed. Like if I have 10 bodies, I should have 20 caps. If I have 100 bodies, I should have 200 caps. If I have 1000 bodies, I should have 2000 caps. So bodies and caps should be produced in 1:2 ratio, and that is the ideal world, ideal scenario. Okay, so something of this type can happen in case of chemical equations also. Suppose, my dear boys and girls, there is a reaction. A plus 2B goes to 4C. A plus 2B goes to 4C. Okay, and I consider case one that I am starting this reaction with 1 mole of A and 2 mole of B. And I ask you, ki beta, how much C will be produced? You will say, sir, chiller problem, sir. Sir, 1:2:4 ratio. So 1 mole of A, 2 mole of B is going to produce 4 mole of C. 1:2:4 is the ratio. Suppose if I ask you that in case 2, beta, this time what I am doing, I am taking 2 mole of A and 4 mole of B. That means I have doubled A and I have doubled B. Then how much C will be formed? So you will say again chiller problem, sir. If you are doubling A and doubling B, C will also be doubled. If you are doubling A and doubling B, then C will also be doubled. So sir, C will become how much? 8 moles, sir. Very good, sir. Very good. Double na? अरे 4 का double यार 8 मोल ना. 4 का double is not 6. 4 का double 8. Okay. And suppose in case 3, if I tell you that I take 3 mole A and 6 mole B, that is I triple A and I triple B. Triple A and triple B. So what will happen to C, my dear boys and girls? How much C will be formed? Once again you will say, sir, chiller problem, sir. It will get tripled, sir. 12. Now listen to me. Listen, everybody. Try to understand the common theme in all these three situations. The common theme in these three situations, what is common? Is that the ratio of initial moles 1:2, ratio of initial moles 1:2, ratio of initial moles 1:2 is same as the ratio of stoichiometric coefficients. Ratio of initial, don't look at the product, just focus on the reactant side. The ratio of initial moles is same as the ratio of stoichiometric coefficients. Whenever this happens, that is, you are taking the initial moles of the reactants in the same ratio as the stoichiometric coefficients. This represents an ideal situation. 10 bodies, 20 caps is ideal situation. 100 bodies, 200 caps is ideal situation. So whenever this happens, it means you have taken the reactants in the same ratio in which they are going to get consumed. Because this gives us the ratio in which the reactants will be consumed, stoichiometric coefficient. And I am taking the reactants in the same ratio. Okay. So now whenever this happens, this is an ideal situation and all the reactants are totally consumed. All the reactants are totally consumed. A will be totally consumed, B will be totally consumed. Alright? A will be totally consumed and B will be totally consumed. So we will write it down. When first quickly complete this, my throat is slightly bad, so just excuse me for a minute. Quickly note it down, all of you. Quickly note it down, everybody. Written? Those who have written, quickly write C in the chat box. C for completed. Those who have written, quickly write C in the chat box, everybody. Okay, so most of you have completed. So our point is, when the ratio of initial moles is same as, write down quickly, is same as the ratio of stoichiometric coefficient. SC stands for stoichiometric coefficient. SC stands for stoichiometric coefficient. When the ratio of initial moles is same as the ratio of stoichiometric coefficient, then all the reactants are completely consumed. When all the reactants are completely consumed, when the ratio of initial moles is same as the ratio of stoichiometric coefficient. SC stands for stoichiometric coefficient. Then all the reactants are completely consumed and moles of product can be calculated. Moles of product can be calculated using moles of any one of the reactant. Moles of product can be calculated using moles of any one of the reactant. Like over here, listen to me carefully. In order to calculate how much C is produced, you can apply grand power on A and C or B and C. Both will give you the same answer. You can apply grand power on A and C or B and C. Both will give you the same answer. And for your mental peace, you can check it also. And just do it orally now. A and C. What is the ratio? 1:4. 1:4. Wait, ready, bhai. Wait. A is to C, what is the ratio? 1:4. So 1 mole will give you 4 mole. 2 mole will give you 4 times 8 mole. 3 mole will give you 4 times 12 mole. 3 into 4, 12. Now between B and C, what is the ratio? 2:4. So 2:4 means what? Double. So 2 ka double 4, 4 double 8, 6 double 12. So whether you apply grand power on A and C or you apply grand power on B and C, you will get the same answer in every case. When this ratio and this ratio are equal, then every reagent is completely consumed. And every reagent is completely consumed and product can be calculated using any one. ठीक है, चलिए quickly note it down. And moles of reactant can be calculated using moles of any one of the reactant. Quickly note this. Those who have written quickly write C. Where ratio is different here? 3/6 is how much? 1/2. 2/4 is how much? 1/2. 1/2 is 1/2 and coefficient is 1/2. Where is it different? It is same in every case, na? Now, acha, you are asking what will happen when ratios are different. That is what we are going to study, don't worry. What will happen when ratios are different, that we will study now. Okay? Chaliye, now listen to me. But it is not necessary that in every factory in this world, bodies and caps are produced in 1:2 ratio only. This is not necessary. This is not necessary that in every factory in the world, bodies and caps are produced in 1:2 ratio. There can be a factory where 10 bodies were made and 50 caps were made. 25 bodies were made and 500 caps were made. This is possible. Yes or no, everybody? Can such a situation exist or not? That it is not necessary that every time the body and the cap are in 1:2. 1:2 is ideal scenario. But it is not necessary that it is every time 1:2 in this world. Sometimes it can be different. Really, your voice is. Can everybody hear me clearly? Is the voice okay, guys? All of you? So please check your network, beta. Yes. So same scenario. Same scenario can happen with chemical equations also, beta. ठीक है, देखो देखो देखो, a plus 2b goes to 4c. Same equation, same equation. But this time I am starting previous slide. Pritam, what happened on previous slide? जल्दी लिखो भाई. Pritam, be fast यार. Write it quickly. So if something is left, you can note it after the class. Don't worry. You will get the QR. So A plus 2B goes to 4C. This is the reaction. And this time, I am starting the reaction with 1 mole of A and 5 mole of B. Initially, I have 1 mole of A and 5 mole of B. Now, first of all, many of you, sir, this is not possible, sir. This is wrong, sir. This is cheating, sir. How can you take 5? Array? Right? In the reaction, they are getting consumed in 1:2 ratio. How much amount I want to take, that is my choice. I can take as much A as I want to take. I can take as much B as I want to take. Okay? So there is nothing wrong about it. This is no cheating. This can happen. Okay? So initially I have taken 1 mole of A and 5 mole of B. This is a very, very normal situation. I can have a factory where one body was there and 5 caps were there. This is possible. There is no harm in it. There is no problem in it. Sir, this is cheating. You can't do this. Of course I can do this. Anybody can do this. Okay? Yes, listen to me now. So now, this time the ratio of initial moles is how much? This time the ratio of initial moles is how much? Ratio of initial moles is how much? 1:5. And ratio of stoichiometric coefficient is how much? 1:2. So these ratios are not equal. And whenever this happens, then all the reagents will not be completely consumed. Initial moles ratio 1:5, stoichiometric coefficient ratio 1:2. Wait a minute. We can take any amount, real me, C15, we can take any amount. I have taken 1 mole to explain. I'll take many examples of this, don't worry. So 1:5 and 1:2, they are not same. So now over here what will happen, bhai? Over here what will happen? Okay, therefore listen to me. For 1 mole of A, how much B you needed? For 1 mole of A, how much B you needed? As per the equation, you needed 2 moles. Consumption was happening in 1:2 ratio. Now 5 to I have taken. Equation is telling me, the reaction is telling me that for one body I need 2 caps. Similarly, this equation is telling me that for 1 mole A I need 2 mole B. 2 mole B. Okay? So for 1 mole A I needed 2 moles of B. For one body I needed 2 caps, but I have taken how much of B? I have taken 5 moles of B. So this means I have taken B more than that was needed. More than that was required. For one body, 2 caps were required, but you produced 5 caps. So if you produce 5 caps means, if you have taken 5 moles of B, means B will be left over. It will not be totally consumed. What will happen in this scenario? Like 1 mole of A needed 2 mole of B, you have taken 5 moles of B. So this 1 mole of A will be totally consumed. Totally consumed. And with 1 mole of A, 2 moles was needed, but you have taken 5. So this will not be totally consumed, and in fact this will be left over. So the reagent which is totally consumed is known as the limiting reagent, and the reagent which is left over is known as the excess reagent. How do we get to know that we have to apply the concept of limiting reagent? When this ratio and this ratio are not same, then 100% the question involves the concept of limiting reagent. The reagent which is consumed first is known as the limiting reagent. The reagent which is left over is known as the excess reagent. And now comes the final point for today's class. The final point is that over here, if I ask you that how much C will be formed, C means product. So there can be one student who gives the answer from A. So if he gives the answer from A, then ratio is 1:4, 4 times. 1A is giving Nagusi. So 1 mole of A is giving 4 mole of C. Okay. If you apply grandpa on A and C, this will be your answer. And another student who gives the answer from B. So here ratio is 2:4. 2:4. Double, 2 times, 2 times. 2 is giving 4. So 5 mole will give how much? 5 mole will give 10 mole. Now which of these two answers is correct? If I ask how much C is produced, then 4 mole is the correct answer or 10 mole is the correct answer? 4 mole is the correct answer or 10 mole is the correct answer? The correct answer is 4 mole, 10 mole is absolutely wrong. Yes. So moral of the story is that product should be calculated using moles of limiting reagent only. Yes, this is not totally consumed. By 5 mole B will give you 10 mole C when this 5 mole will be consumed. When this will be totally consumed, then you will get 10 mole of C. Otherwise, you will not get 10 mole of C. Okay, so whenever question asks that how much product is formed, then we have to apply the grandpa equation on limiting reagent and then calculate. Only moles of limiting reagent will be used for any calculation. Moles of limiting reagent will be used for doing any sort of calculation. Is this understood or not, everybody? How much is left, Lakshmi Ram? We will discuss that tomorrow. That is not the agenda right now. Okay, but answer for this cannot be 10 mole, it has to be 4 moles only. Moles of product should be calculated using moles of limiting reagent. So we will quickly note this down, and then many interesting things related to limiting reagent we will be discussing in tomorrow's class. Okay, so we will make a note of it very fast. When ratio of initial mole and stoichiometric coefficient. How can we find limiting reagent? Digvijay, very good question. It will be the first thing which we discuss in tomorrow's class. Okay, first thing which we discuss in tomorrow's class will be this only. Okay, how to find the limiting reagent. When ratio of initial moles and stoichiometric coefficient are different, then one of the reactants is completely consumed and one of the reactants is completely consumed. One of the reactants is completely consumed. Today no homework, just revise whatever we have covered. The one which is completely consumed, we can say completely consumed first. Completely consumed first. Called NR. NR means what? NR means what? Limiting reagent. And the other reagent is left over, called ER. What if both the reactants are taken in excess? Pawan Kumar, that cannot be the case. I will explain that to you tomorrow. All of you are asking me very good questions and I am really appreciating that. But this doubt of yours will be clarified tomorrow. How to find the limiting reagent will be clarified tomorrow. ER means excess reagent. Okay. Called ER means excess reagent. And how much excess reagent will be left will also be clarified tomorrow. Okay. So we'll be talking about these 2-3 things. Pawan Kumar ke, what if both reactants are taken in excess? That cannot happen. That is not possible. How? You will understand it tomorrow. Okay, I completely understand your doubt. Okay, but have patience till next class. Tomorrow this will be the first thing which we will discuss. Okay guys, chaliye, so that is it for today, and very quickly I'll share the QR code with you. Insta ID is shm@0708. 1 minute, 1 minute. Okay, so this is the code. Telegram ID is also same, I think. Insta ID is SHIVAM 0708. Telegram is SHM@0708. Insta is SHIVAM SHIVAM 0708. Chalo bhai. Okay. So that's it for today. KCLO 3 question. To next class I will explain. Okay. I have to rush for another class very quickly after this. All right. Chalo, bye students. Love you all. Take care. And eagerly waiting for you all to be here. Let's hope my throat improves by tomorrow. And I'm back to my usual self. Chalo, bye everybody. Thanks a lot, everyone. Thank you. Bye everyone. Bye bye. Take care everyone. Bye everybody. Bye.